Good day, folks. Thank you for finding your way here however you did. I appreciate it. We'll be going over more basic color theory in this video, this being part 2 of this color theory series. So if you haven't already, you may wish to check out part 1, in which we went over quite a bit, including the color wheel, color relativity, as well as some general terms such as analogous and monochromatic and what they mean. However, you can still follow along with this video regardless of whether you've seen the first or not. This video is mostly dealing with additive versus subtractive color models, the differences between them, and why it matters for you as an artist, photographer, designer, or someone simply trying to learn more about color. So without further ado, let's jump in. Okay, so in the first video we went over the color wheel, which looks something like this. Unfortunately, that's only half the story. The other part looks like this, which might seem intimidating or confusing at first, so let's break it down a little bit. Let's start with red, green, and blue, so RGB, and cyan, magenta, and yellow. We'll call this CMY for now. And for those of you familiar with printers, probably know where we're going with this. Now, on the right will essentially be our primary colors of light here, RGB. And on the left will be our primary colors of pigment. Now we'll come back and explain this a little bit more later. But for now, let's see what happens when we mix these colors. Here we see mixing red and green gives us yellow, mixing green and blue gives us cyan, mixing red and blue gives us magenta. And on the other side, mixing magenta and yellow gives us red, mixing cyan and yellow gives us green, and mixing magenta and cyan gives us blue. And if you don't have all of this memorized yet, don't worry. Boom, we're back where we started. So now let's talk about why these colors work this way and discuss the differences between additive and subtractive color models, as well as what that means. So CMYK is used in printing, which you may have noticed a printer has ink cartridges labeled cyan, magenta, yellow, and black, CMYK. However, fun fact, the K technically stands for key, not black, like many people rather reasonably assume. Now we'll come back to CMYK in a second, but first let's go over RGB right now, which is an additive color model. This is the model that the computer screen you're watching this video with right now is using. So let's talk about how it works. The RGB additive color model works in terms of light. So basically red added to green added to blue equals white. Additive. Let's look at a visual representation of what this would look like in real life. Here we have red light, green light, and blue light all shining on a dark wall. The result looks pretty similar to what we had before, as opposed to CMYK. The CMYK subtractive color model works in terms of pigment. And this model, combining red, green, and blue, gets us black. So unlike light, which is additive and adds up to white, pigments are subtractive and combine into black. We see subtractive color mixing every day in things like ink and paint. For example, if you mix red, green, and blue paint up, you'll get black. Let's talk about why this is. Okay, so we're going to put 1s next to our 3 primary pigment colors, cyan, magenta, and yellow. Next, we're going to put 2s next to our secondary pigment colors, and we'll explain why we did this in a moment. But first, an example. Say you're wearing a red shirt when white light, which we now know is made up of red, green, and blue light, hits your shirt. What happens is your shirt absorbs all the color that hit it except for red. The shirt reflects the color red, and so that's what we see. Think of it almost as a barrier, which only lets the color that it happens to be pass through. Now for clarification, let's look in a little bit of a different example. Try and help us out. So if our shirt is blue, then it would absorb all the colors that hit it except for blue, and we'd see blue. White minus red and green equals blue, subtractive. And finally, if we were wearing a green shirt, then the equation becomes white minus red and blue equals green. Okay, so now we're going to back up a little bit and go over those numbers we talked about earlier. Now looking back at our red shirt example, we see here that a black circle appears around green, blue, and cyan. This is because these are colors that red subtracts. Basically, red subtracts 2 colors, green and blue. However, as we saw before, mixing green and blue gives us cyan, so cyan is subtracted too. Now let's look at our blue shirt example. Here, blue subtracts red and green, as well as yellow, which is made by combining red and green. Same deal for green, subtracting red, blue, and finally magenta. Alright, so now let's look at what would happen if we were wearing a yellow shirt. Here, yellow subtracts only one color, which is why we placed that 1 under it earlier. And the color that it happens to subtract is blue, which is on the opposite of it. And so white minus blue equals yellow. This is because all we're left with is red and green, which is yellow. This will be our last example. A cyan shirt, which is opposite red, and so cyan subtracts red, and we're left with blue and green, which combine to make cyan. Alrighty, and that'll do it for this video. If you have any questions, feel free to leave it in the comments below. Thanks for watching. See ya.